Alright, so in this problem we have a wooden box here that is suspended from a wire. And we want to know how much this wire stretches due to the weight of this particular box. Now since we're asked for how much does it stretch, that implies elasticity of length because we need to solve for delta L. So I've written down my elasticity of length equation here. Now the first thing we need to do is find the force due to tension. So we need to go back to topic 2 and understand that there's a force of tension pulling up on the wooden box and then the weight of the box is pulling down, and those should be equal and opposite to each other because the system right now is at rest. So we can say that the force due to tension minus the weight of the box equals mass times acceleration in y, and because the box is not accelerating the y, they equal to 0, so force of tension equals the weight of the box, which equals m times g. And so I plugged in m times g here for the force due to tension. Alright, so this is a wire and we're given the radius, so that tells us that our cross-sectional area is going to be the area of a circle, so I've used pi r squared here. Make sure that you convert your millimeters here before you square it. Then we need to look up the Young's modulus, so this is the Young's modulus given in the constant table that's linked in Blackboard. And make sure you're looking up steel and not wood because we need to look up the Young's modulus for what is actually being stretched. We're trying to find delta L, and then the 10 meters is the original length of the wire. So when we solve for delta L, we get 2.1 times 10 to the minus 3 meters, or 2.1 millimeters. Part B of this question asked is what would happen if the system was accelerating instead. So let's say we have a positive acceleration. We would go back here, and so when we solve for force due to tension, it would end up equaling mass times acceleration in y plus the weight of the object. So that means the force due to tension would increase if you had a positive acceleration, or the force due to tension would decrease if you had a negative acceleration. So the force due to tension you still need to find by summing forces. You can't just assume it's equal to the weight of the box.